Hello, Professor. Today I'll discuss the global health impact of tanneries in RANIPET, Tamil Nadu, India, using data from studies on groundwater contamination and chromium exposure in 2021, and tannery effluence effects on soil and water in 1992. So what are tanneries? Tanneries process raw animal hides into leather, with RANIPET being a major hub reliant on chemical tanning. Untreated effluents from these tanneries release hazardous metals like chromium, cadmium, and arsenic into water sources, posing severe health risks like cancer and organ damage. The purpose of this presentation is to illustrate the environmental and health impacts of tanneries in RANIPET through an analysis of key contamination data and historical developments. The objectives are to highlight the historical expansion of tanneries and its environmental consequences, analyze contamination data to demonstrate the severity of heavy metal pollution, and lastly, explore regulatory measures and sustainable practices to mitigate industrial pollution. Here are the contents of my presentation, starting with a brief history of tanneries in RANIPET and ending with my takeaways from the assignment.
The history of tanneries in RANIPET, India reflects their crucial role in global leather production alongside significant environmental and public health challenges they pose. This timeline outlines their evolution, drawing on key data and insights from the assessment of groundwater quality and P. comprehensive study on tannery pollution. In the early 20th century, vegetable tanning dominated with minimal environmental harm. In the 1940s to 50s, chrome tanning introduced over 250 chemicals, marking the start of environmental degradation. In the 1970s to 80s, industrial expansion led to untreated effluents contaminating the Pala River and groundwater. Toxic levels of chromium affected agriculture and drinking water. In the 1990s, public health crisis emerged, with residents reporting skin disorders and respiratory issues. Regulations for effluent treatment plants were introduced but were weakly enforced. In the 2000s, cleaner production techniques like zero liquid discharge were adopted, but contamination persisted. In the 2010s to present, emphasis on sustainability grew, but legacy pollution remains a challenge.
Figure 1 shows the geographical map of the industrial area of RANIPET. This region is one of the largest hubs for leather tanneries in India and has been a focal point for environmental studies due to significant groundwater contamination. The map highlights key water sampling locations, categorized into hand pumps, open wells, and bore wells. These sampling points provide insights into groundwater contamination levels at various locations within and around the industrial zone. Many sampling points are situated near tannery clusters, represented on the map as industries. These industries are known to discharge untreated effluents containing heavy metals such as chromium into the environment. The close proximity of these industries to residential areas and water sources exacerbate health and ecological risks. The spatial representation is critical for identifying contamination hotspots and understanding how industrial activities, particularly tanneries, impact local water sources. This line graph illustrates the alarming rise in chromium levels and groundwater in RANIPET over the years, driven by extensive tannery operations in the region. Chromium is a major contaminant released during the leather tanning process, and its concentrations have consistently exceeded the World Health Organization's permissible limit of 0.05 milligrams a liter, which is marked as a reference point on its graph. In the early 1990s, chromium levels were measured at 0.08 milligrams a liter, already surpassing safe levels. By the 2000s, concentrations reached 0.1 milligrams a liter, reflecting increased industrial activities. By 2010, chromium levels climbed to 0.15 milligrams a liter, and in 2020 they peaked at 0.2 milligrams a liter, which is 4 times the safe limit. This growing trend underscores the inadequate regulation of industrial effluent disposal and highlights the urgent need for effective wastewater management systems. Elevated chromium levels in drinking water are linked to serious health risks, including carcinogenic effects and organ damage, emphasizing the critical nature of addressing this issue. This bar graph depicts the concentrations of 4 key heavy metals, chromium, cadmium, lead, and iron in RANIPET's groundwater based on 2016 data. It shows the minimum, maximum, and mean concentrations in milligrams per liter, and the logarithmic y-axis effectively highlights the disparities in contamination levels. Chromium, with a maximum concentration reaching 40.52 milligrams per liter, far exceeds the WHO limit of 0.05 milligrams per liter. Chromium contamination is primarily linked to tannery effluents. For cadmium, although lower with a maximum of 0.004 milligrams per liter, cadmium's toxicity makes even trace amounts hazardous. Lead, with a maximum level of 0.053 milligrams per liter, surpassed safe drinking limits, likely due to industrial discharge. Iron, with a maximum concentration of 0.57 milligrams per liter, though partially natural, indicates amplified contamination from industrial activities. The data highlights severe contamination, particularly from chromium, posing significant health and environmental risks. Urgent remediation, stricter regulations, and improved wastewater treatment are critical to mitigate the impacts of these pollutants on human health and the environment. The Water Quality Index table in 2019 categorizes water quality into 5 classes for a total of 40 samples. Over 55% of the samples fall into the poor and non-potable categories, indicating critical contamination. With no water rated as excellent and only 10% as good, this table starkly demonstrates the unsuitability of RANIPET's groundwater for drinking purposes. This analysis highlights the pressing need for remediation strategies to protect public health. To conclude, RANIPET's tanneries have left a lasting environmental and health legacy. Chromium contamination far exceeds the WHO standards, with over half of the groundwater sources unfit for use. Health risks include cancer and organ damage, while ecosystems and agriculture suffer extensively. Although steps like zero liquid discharge and effluent treatment plants have been introduced, they fall short in addressing decades of damage. This presentation underscores the urgent need for stricter enforcement of environmental regulations, sustainable practices, and global advocacy.
Thank you.